All right, so we're doing section 3.1, solving systems of equations by graphing. There are three different ways that you can solve systems of equations. So a system of equations is a set of two or more equations. So it's not just trying to solve one equation, but you're trying to solve both of them at the same time. For us, at least both of them. And there's three ways you can do it. You can do it by graphing, which is nice if you use nice, perfect straight lines. But sometimes when we're graphing them and we look to see where the two lines crash into each other, they don't always crash at perfect places. So then you have to approximate what the solutions are. So solving by graphing isn't the best way to do it, but it is a way to do it. Okay, not my favorite way for sure. It's not because it's difficult. It's just because I know that if my lines aren't straight, my answers can be wrong. So yeah, graphing not the best, but it is one way. After that, there's one called substitution. That's section 3.2. We'll get into substitution after that. And then section 3.3 is elimination and sometimes elimination with substitution. That's all section 3.3. You'll notice we teach section 3.3 in 2 days when we do it because one of them is like the easier way to eliminate, then a little bit more complicated way to eliminate. So there's three different ways. So graphing, substitution, and elimination. Okay, my personal favorite is substitution, but some other people prefer elimination. Most of us agree that graphing it is the least accurate. Okay, but it works. But it's not always the best. Okay, so one of the things they're going to be asking you in the homework, and one thing you guys should know, is how can you tell how many solutions a system of equations has? Well, you can do that by looking at the slope and the y-intercept. Okay, so you know it has one solution if the lines are not parallel. Okay, so if the lines are not parallel, they're going to cross each other at some point, right? They're going to intersect at some point. So they have one solution because they cross each other at one point. So I kind of put that the lines cross each other at one point. So not parallel, one solution. Okay? If they are parallel, there's no solution. Okay? But notice how I put right there in green, it says the y-intercepts are different. So if they have the same slope, but the y-intercepts are different, that means that the two lines are basically crossing, they're not going to cross each other and they're on different areas, right? So they're just parallel. And we know parallel lines never intersect. So if they don't intersect, they have no solution. Okay? So if they are parallel lines, okay, with different y-intercepts, parallel lines, then there's no solution. And again, one solution as long as they're not parallel. So their slopes have to be different. Okay? If the slopes are different, they have one solution. If the slopes are the same with different y-intercepts, then no solution. Well, what's infinitely many? Well, the lines are parallel, just like with no solutions. The lines are parallel, but they have the same y-intercept. In other words, they're the same equation. Okay? So if two lines are the same equation, eventually, like when you simplify it out, you get infinitely many solutions. Okay? So again, let's just review it real quick. You have one solution if they're not parallel lines. Okay, so we just got to check their slopes. If they're not parallel, you got one solution. If they are parallel, it can either be no solution or infinitely many. The way you know which one it is by the y-intercept. If the y-intercepts are different, you have no solution. If the y-intercepts are the same, infinitely many solutions. Okay, so that's what we're basically looking at in the first set of examples. So the instructions right here, I say, do these systems have one solution, no solution, or infinitely many solutions? All right, so the instructions, as it says, do these systems have one solution, no solution, or infinitely many solutions? Remember, everything depends on the slope and the y-intercept. So in order to figure that out, we're going to solve for y. Okay, so in order to solve for y, let me get the x value, and I'm going to throw it over to the right side. So I'm going to get negative y is equal to negative x minus 2. And then I'm going to divide everything by a negative 1. So divide by a negative 1, divide this by a negative 1, and this by a negative 1. So y is equal to, that's x plus 2. My slope is 1. My y-intercept is 2. Okay, notice how I immediately wrote down the information that's important, the slope and the y-intercept. Okay, now let me go to the other problem. So I'm going to solve this one for y. So I'm going to move the x over. So I get negative y is equal to negative x plus 2. I'm going to divide everything by negative 1. So I get that y is equal to x minus 2. So my slope is 1. My y-intercept is negative 2. So then I'm going to go through those three things, okay? The three things up here. One solution, no solution, infinitely many, okay? So if it has one solution, the slopes are different, right? They're not parallel. Are these slopes different? No, m equals 1, m equals 1. So the slopes are the same. If the slopes are the same, they're either no solution or infinitely many solutions. It depends on B. Is B the same for both? No. So if they're parallel and B is different, what is my answer? No solution. No solution, right? That means they're parallel lines. So I'm just going to write no solution. So all we did was basically solve for y, and then we looked at our slopes, okay? And we noticed our slopes were the same. That means the lines are parallel, right? Well, if the lines are parallel, they can either have no solution or infinitely many solutions. The way they have no solution is if the b's are different. Now, if I would have gotten b equals 2 and b equals 2 with m equals 1 and m equals 1, that means this would have been infinitely many solutions. Okay, you could put IMS if you want. Okay, so if this right here would have been a 2, then my answer would have been IMS, infinitely many solutions. Because the slopes are the same and the y-intercepts are the same. Infinitely many solutions. But since, whoops, let me fix this really quick. But since they do have the same slope but different y-intercepts, then it's no solutions, okay? That means these lines are parallel. Are we okay with the first one? So notice not a lot of crazy stuff. It's just once you solve both for y, label your slope and your y-intercept and then go through that list. Do they have the same slopes, yes or no? Because if they don't, one solution, right? If they do, parallel, so it can be no solution or infinitely many. All right, so let's check this one out. Same instructions, okay? I just got to solve both of them for y. So I have 4 equals to negative 3x minus y, and 0 equals to negative 6x minus 4 plus 2y. So I'm going to move things to the left, and then at the end I'll just rewrite it if you guys don't mind. So I'm going to move the negative 3x over. That becomes a 3x plus 4 equals to negative y. And then I'm going to divide everything by negative 1 to get y all by itself. So divide this by negative 1, this by negative 1, and this by negative 1. So I get negative 3x minus 4 is equal to y. Okay, so what's my slope for this one? Negative 3. And what's my y-intercept? Negative 4. Thank you. Now we go over to b. I mean, not b, the second part. So I'm going to solve for y again. So I'm going to move the negative 6. And if you guys don't mind, I'm also going to move the negative 4 over at the same time. I'm going to do 2 steps at once. Because we're just moving stuff over. We're not having to divide everything. So I'm going to move the negative 6 over and the negative 4 over. So that's going to give me a 6x plus 4 equals to 2y. Okay? So 6x plus 4 equals to 2y. Now, I'm going to divide everything by 2 now. So everything gets divided by 2. So I get 3x plus 2 equals y. What's my slope? Well, the 3 and then my y-intercept? 2. All right. So now I go through my list. Are these lines parallel? Or do they have different slopes? They have different slopes. If their slopes are different, if they're not parallel, then how many solutions do I have? One solution. And that's it. One solution. Okay? So by definition, if the slopes are different, that means they cross each other, right? If they cross each other, one solution. Okay? If the slopes are the same, that means they're parallel. And now it depends on B. If B is identical, infinitely many solutions. If B is different and the slopes are the same, you get no solutions. Okay? Again, that's all that what I wrote up here. Okay, if you came in a little late, I'll put it up at the end. Okay? But everything I stated right now is based on those 3 definitions. All right? Are we okay with these? We're going to move on to actually graphing these things. Because besides being able to tell me it has one solution, no solution, stuff like that, we got to make sure that you can find the solution if it does have one, right? So right now we're going to figure that out by doing it graphically. Okay, so I think we have 2 examples and that's it. So yeah, it's not a super long lesson, but we have 2 systems, or a system of equations, okay? By the way, on your homework, they always like to write the systems one on top of the other. You're going to notice I always write them side by side because usually you got to solve for y. Okay? So unless you're lucky enough and they already give them to you solve for y, then that's great. But if they don't, you're going to have to solve for y. So I always put them side by side because as you guys can tell, I work vertically, right? I don't like to work side to side. I like to work vertically, top down. It makes my work easier to follow. If I make mistakes, I can find them a little bit quicker. So I always work vertically. So let's solve both of these for y. You guys can beat me to it if you want to. It's not a big deal. But here we go. I'm going to move the 7x over. So I got 2y. Right here, 2y equals negative 7x plus 6. Okay. Yeah, that would be that. And I'm going to divide everything by 2. So y is equal to negative 7 over 2x plus 3. Okay, so I'm done with that one. Now I'm going to solve the other one. I'm going to move the x over. I get 2y equals to negative x minus 6. Okay, and then I'm going to divide everything by 2. So I get y is equal to negative half x minus 3. It is negative x over 2, but there's a 1 in front of that x, so negative 1 over 2. That's how I got negative half x minus 3. So I got 2 equations. Now I get to draw a graph. So I'm going to probably make like a 4 by 4, maybe 5 by 5. We'll see. Again, you guys will be given a graph to use. I'm going to make mine a little bit on the bigger side just in case. One, two, three, four. So I actually made it a 6 by 6. And then we're just going to graph these things. We should be used to graphing this. We've been graphing absolute values already. We've graphed lines. So there shouldn't be anything that's like, oh my gosh, not this again, right? We've done it a couple times. So I'm going to switch back to red so we can draw the red line. Then I'll go to green so we can draw the green line. And then wherever they cross will be my solution. Okay, and I want to try my best to draw a nice straight line. Okay, so starting at a positive 3 for the red line, okay, I begin at the y-intercept, that's 3, and then my slope is negative 7 over 2, 7 down, 2 over, so 1, 2, 3, 4, 5, 6, 7, 2 over is right here. Try my best to draw a nice straight line. No guarantee. Well, actually, I can guarantee it, but it may not be perfect even then. So here's a line. Okay. So trying to use like a ruler or an ID card, something like that will be helpful. That's what I recommend, but it's up to you. And then my next line, my green one, says start at -3 and then go down once and twice over. Down once, twice over. That's actually right here. So I got kind of lucky. They cross over each other at a point that was already there. So that's good. So I'm going to draw my line right here, as straight as I can. And again, I'm kind of cheating because I got a digital format here so I can extend it nicely, right? So there you go. All right. So the answer is where they cross. Where do they cross? To -4. So my solution is 2, -4. This is my solution. Now you can imagine if I kind of just drew it by hand without trying to be real clean and stuff, maybe I don't cross at that point. Maybe I cross a little lower or a little higher. So my answer could easily be wrong if I'm not careful. Okay? So that's why I'm telling you, solving by graphing is not necessarily the best way to do it. It's a way to do it. Like I said, I got lucky. My points happened to cross exactly where there was already a point. So that's good, but sometimes they don't always cross where there's already a point. Okay, and then you're going to have to approximate a solution, and approximations are not exact answers. They're approximations, right? They want exact solutions. So are we okay with this one? So just solve for y. Once you solve for y, graph it, look to see where they cross. So we'll do one more. So here's number 4, example number 4. -3x plus 4y is equal to -16. I also have -16 plus 3x equals to 4y. We're going to do the same thing we did before. We're going to solve for y. We're going to find our slopes, our intercepts. We're going to check out to see what kind of equations we have. We'll graph them, and then from there make our decision in terms of solutions. So we'll start off with the one on the left side. Let me move the -3x over to the right. So I get 4y is equal to 3x minus 16. And then I'm going to divide everything by 4. So divide by 4, divide by 4, divide by 4. So I get y equal to 3/4 x minus 4. So I know my slope is 3/4. I know my y-intercept is -4. Okay. Now let's solve for y on the right side. Well, all I have to do is divide by 4. Okay. So if you guys don't mind, I'm going to rearrange the left side to put the x in the front. So 3x over 4 minus 4 is equal to y. You guys notice anything interesting? They're the same line. So how many solutions do I have if they're exactly the same line? It's IMS, right? Infinitely many solutions, right? Because according to that definition, the slope is the same, 3/4, 3/4, and the y-intercept is the same, -4, -4, right? So let me just graph them. I'm going to graph them both on top of each other, but it's going to look a little odd. But I mean, that's basically what they want. So, give me a second. Try doing a 5x5 instead of a 6x6 here. I didn't make it nice and clean, but that's okay. It's 6 side by side, it's 5 up and down. So if I graph the red one, -4 is where I start, and then 3/4 of a slope, so -4, I start here. 3 up, 4 over. there's my line. I'm not going to make this one like nice and clean because I want there to be a little bit of a squiggle in between so you can see both lines, right? I don't want it to be so perfect that one line covers the other. And then the other equation is 3/4 x minus 4, so I still start at -4. I still go up 3, 4 over, so notice my points are the same, okay? And then when I draw my line, okay, and there you go. So ideally, you should only see one line, but I'm showing you both because my lines are a little crooked, which is exactly what I wanted you guys to see. But ideally, it should only be one line. It's literally two lines, but the thing is, one line is on top of the other, right? So one line is on top of the other. If the solutions are based on how many intersections they have, right? So if they cross like an X, there's one answer, right? Because they cross one time. If they are on top of each other, that means that one line is touching the other line an infinite number of times. That's why we say an infinite number of solutions, because they're laying on top of each other, okay? Every time they touch, it's an answer. Well, if they're on top of each other, they're touching at every single possible point. So we call it infinitely many solutions. So this would be IMS, okay? So I'm going to write it out and then I'll put the abbreviation. You don't have to do both. As long as you put IMS, that's fine, okay? But this is what your homework is going to be like. Part of it is going to ask you how many solutions does it have, and then it's going to ask you find them by graph.